Welcome to a RoboDemo case study carried out by the AIM Centre in Sligo, funded by Interreg NPA. In this video, we will go through an overview of the case study at hand, the potential challenges, the approach taken by the AIM Centre, and eventually the findings of the use case. This case study looks at the feasibility of using a collaborative robot, or cobot, in a sheet metal fabrication SME named Weldits. While robots are commonly used in industry for repetitive welding tasks, this SME sought to explore their feasibility for a bespoke fabrication model. In this case, the challenge lies in the need for a new robot program for each unique welding scenario, often making manual welding more efficient. AIM started with a site visit to the factory to get a better understanding of the company and their specific needs. The team then returned to the AIM Centre to review the preliminary findings and carry out more in-depth research. AIM's objective was to evaluate the feasibility of deploying a robot or cobot for the SME's needs. The process started with an analysis of real-world welding cycle times, followed by a technical review of tasks a robot could handle. The findings showed that actual welding is only a small part of the welder's overall responsibilities. Here you can see an example where AIM calculated hypothetical estimates of tasks involved in the welding process, showing that less than 40% of the total weld cycle involves the actual welding. After assessing the current process flow, we tested improvement scenarios, including lean-only changes and robotic integration. The best results combined both, saving 1.5 minutes per 17-minute cycle. By automating complex welding tasks with a robot, a less skilled worker can now handle setup and takedown, freeing up skilled welders for more critical tasks. Achieving savings of approximately €8 per hour has resulted in over €70,000 in cost reductions over 5 years, making the investment in robotics feasible. The next step was to explore off-the-shelf robotic solutions suited for bespoke welding. Notable technologies included quick-teach tools, enabling operators to teach custom welding routines more efficiently. The team also reviewed the potential to look at hiring a cobot welder as a trial option and to assess long-term feasibility or deal with particular projects. Options such as Hirebotics in the US offered a cobot welder for rent, while one Irish company offered a 3-month lease for approximately €3,000 per month. Related technologies for programming were also explored. On the right is RoboDK, a plugin software that integrates with CAD tools like SolidWorks, allowing users to select edges in the CAD model to generate cobot programs, improving efficiency while preserving design intent and design for welding. On the left is MottoSense by MottoMan, which uses laser scanning to automatically and precisely detect weld seams. Upon completing the research, AIM used simulations to evaluate how semi-off-the-shelf solutions could be applied to meet Weldit-specific needs, including potential limitations. The technical focus was on determining which tasks a collaborative robot could handle, what would still require human involvement, and the additional steps needed to set up the robot. A number of key technical findings were identified. First, in addition to teaching the robot to weld, the operator would need to set up more precise jigs to hold the parts. This is necessary because robots cannot automatically adjust for positioning errors smaller than a millimeter, which may arise due to warping during the welding process. While there were health and safety improvements due to reduced operator exposure to fumes, new risks were introduced by having an unguarded quick-teach robot in the workplace. On a positive note, robotic welding is a growing focus in the collaborative robot market, making it increasingly viable both technically and financially. Moreover, when parts are set up correctly, the consistency and quality of robotic welds surpass that of an average human welder, which is a significant advantage for companies working on mission-critical structural components. The key findings included a positive ROI, particularly in repeat manufacturing. Another benefit was the development of internal skills, positioning the company ahead in technology. Additionally, it created new business opportunities, enhancing competitiveness in other areas.